North America since 1920. Mass fossil fuel consumption and emissions. Coal mining and harmful off-gassing when burned. Mass oil spills into our oceans. North America today. Dependence on motorized transportation with a reliance on fuel. Large-scale oil drilling. The burning of Kuwait oil fields. Production of the pipelines. Mass clear-cutting of forests. What are the options? What can we do to mitigate the divide between using natural resources and our dependence on fossil fuels? Solar energy is the conversion of sunlight to electricity or thermal heat. It is the cleanest and most abundant renewable energy source available, since everyone in the world has access to sunlight. The conversion of solar energy to electrical energy is used by photovoltaic systems, also known as solar panels. This method converts solar radiation into direct currents of electricity. The panel's cells capture the sun's radiation, causing photons, the particle that carries the energy, to dislodge a flow of electrons, which produce the electric current. This environmentally friendly system can be implemented into designs on roofs, standalone sunshades, or as solar shelves. The conversion of solar energy to thermal energy is processed through evacuated tube collectors. This system consists of a series of durable, transparent glass tubes, one inner, one outer, between the tubes. Oxygen is removed and the tube is vacuum sealed shut to prevent loss of heat through convection or radiation. This also allows the tube to retain the heat at a much greater rate. Once the sun's radiation is captured, the fluid circulating the copper pipe is heated and causes hot vapor to rise to the top. That heated fluid then circulates to the storage tank, heat exchange, to be used for water and other heating applications. Evacuated tubes have been proven to be highly efficient due to their circular design, as it allows sunlight to pass in from most angles. As seen at the Van Dusen Botanical Gardens, this method of renewable energy can produce enough heat with excess all year round. Geothermal energy. Geothermal energy derives heat sources below the Earth's crust as usable energy. Since the ground absorbs nearly half the solar energy our planet receives, it remains at a stable 55 degrees Fahrenheit all year round. A geothermal heat system consists of a series of heat pumps that remove heat from the energy supply source in the ground. As water circulated through the pumps, it conducts the thermal heat from the earth and transfers it to the building's energy distribution system through a heat exchanger to be dispersed. In the warmer months, the process is reversed, so that heat pumps collect heat from the building and circulates it back down to the earth to be deposited into the ground, providing cooling. Wind power is a natural form of solar energy and is the result of uneven heating of the atmosphere by the sun. Wind turbines are usually seen in large groups known as wind farms. 3/4 of the US produces wind energy on a large scale already. Most turbines appear to be small in size, but in actuality, they can reach up to 200 feet tall with blades as long as a football field. For wind turbines to be productive, the blades need to be spinning at 18 kilometers per hour. The computer inside the box at the top of the turbine controls the direction of the blades. The blades are connected to rotors that allow the blades to spin faster, generating more energy that is then turned into electricity and sent down the shaft to the power grid. There are two types of turbines, first being the most common type, vertical axis. the second being a horizontal axis, also referred to as the egg beater turbine. The reason for having two types of turbines is mainly due to its location and sometimes spatial restraints. More recently, we have started to see offshore wind farms. As studies show, the winds are greater out to sea. We're able to collect more energy and send it to shore. An example of a well-known wind farm is the San Gorgonio Pass wind farm in Palm Springs, California, where over 4,000 turbines create enough energy for the entire Palm Springs-Coachella Valley. Another example is the Grouse Mountain turbine that stands 212 feet tall and generates 25% of the mountain's energy. Tidal power is created from the moon and the sun's gravitational influence on the ocean. Tidal plants can only be installed along coastlines as high and low tides are key. Tidal barrage is a dam-like structure used to capture the energy from high and low tide currents passing through the turbine cavity. Tidal barrage, being the most common form, allows the high and low tides to pass through the dual-moving turbine, creating energy. Tidal turbines use the force of the ocean currents to rotate the turbine that is connected to the generator producing energy. Because water is 832 times denser than air, the underwater turbine doesn't have to rotate as fast to produce the same amount of energy. Tidal turbines not only create jobs, they are renewable, create no greenhouse gases, and are environmentally friendly. Tidal turbines are a predictable energy source, allowing us to calculate the exact amount of energy that will be output. This way we can strategically place them to maximize energy received. So why would you use alternative energy if what we have already works? It will reduce our reliance on fossil fuels, which is a quickly depleting resource that is extremely harmful to the environment. It is reliable. Natural resources such as wind power, tidal power, geothermal heating, and solar energy will always be around. It is everlasting and will continuously provide energy. It creates jobs for us and future generations such as maintenance, installation, manufacturing, operations, and transport. Most importantly, we should implement these renewable resources in our future designs to prevent further global warming and environmental issues.